So this lesson is pieced together a bit. We were supposed to learn something called binomial expansion before we did this lesson, but we're kind of skipping around a bit. We'll come back to binomial expansion if we have time. So I'm skipping over all of this because it's not in our current notes packet, and we are going to skip to, it's called Worksheet 7b, and it's called binomial theorem and binomial probability is what we're going to be looking at. So again, I'm skipping over a few slides here. I'm just trying to find where your notes actually begin, which is right here. So there we go. Binomial probability is used when you have a 50-50 chance of, well, that's not really a good way of saying it. But there's only two outcomes, so either you will have a success or a failure. You can't like sort of succeed and sort of fail. So if we know we have a binomial probability, we can use our formula that is given to us here that involves combinations. The other option is we can use binomial probability distributions on the calculator, and I'll show you both ways, and then we're all going to decide that the calculator's distribution option is much easier, so we're going to probably use that, but you're welcome to go back and use this method. So on your notes, I would like you to recognize a couple of pieces of this formula, the first one being right here. I have NCX, that's a combination, right? So N is the number of trials, and then the X is the number of successes. See what that means in context coming up here. And then there's a P, which is the probability of success. And then there's Q, which represents the complement to that, which will be the probability of failure. So again, remember these probabilities only have two outcomes. So like if it's a 70% chance of success, that means there's a 30% chance of failure. So that N and X show up a few times in the formula here. This first problem that we're going to do is the golf problem. Let's do that one. I'm going to show you using that combination formula, and then I will show you on the calculator. So our golfer can drive a ball into the fairway 70% of the time. So right there, that is our probability of success. We're going to write it as 0.7. And then that also tells me that my probability of failure, or Q, is 30%, so 0.3. I'm going to keep reading. We're going to find the probability of hitting it into the fairway 14 out of the 18 times, because there's 18 holes in the round of golf. So the 18 is the total number of trials, so that's the N in the formula. And 14 would be how many successes we're looking for, so that would be the X in the formula. So using our combination formula, I would set up 18 combinations of 14 times probability of success, so 0.7 to the X power, so 14. So 14 times we're going to win, if you want to call it that, times 0.3, and then it says N minus X, so how many times you lose or don't make it to the fairway would be 4 times, 18 minus 4. So this is what I would type in my calculator, exactly how I have that written. So let me go pull up my calculator. Or not. Oh my goodness. Computer's like dying a slow death here. Okay, so while my computer decides to not work anymore, I'm going to tell you, on your calculator typing this in, you get 0.168. Now, this next part I need the calculator for, so let me pause the video and see if I can get things to work. Alright, figured it out. Alright, not graphing anything today. So going back and typing in what we just had, that combination formula, it was 18 combinations, so go grab the probability combinations feature, 14 times, I'm going off memory, I think it was 0.7 to the 14th power, get out of the exponent, times 0.3 to the 4th power. Alright, so, yes, we get 0.168. Bit of an irritating formula, right? So I'm going to show you another way we can get the same answer. It's in our distribution menu. So if you go to second and then the varies key brings us to our distribution menu, and you scroll up or down, it doesn't matter, it's kind of towards the bottom of the list. There's two binomial options. One's called binomial PDF and one's called binomial CDF. We'll use CDF at another time in our stats unit, or when you go to stats class. CDF is the cumulative calculation of everything from one point down the distribution curve. We're going to be doing PDFs right now in PreCalc. So always choose PDF. Now this is the template for the newer operating system on the newer calculators. If you have an older calculator, I'll show on the screen next how you're going to type it in. But for these newer ones, number of trials were the 18 holes of golf. Probability of success was 0.7. And then X value, how many successes we were hoping for, was 14. And then they want you to paste, which is kind of weird, right? So they paste this into, this is how we're going to type it in our older calculator. So if you have an older calculator, you have to know that the first number is the number of trials, and then P successes, probability, and then X number of successes. So we're going to have to jot that down for a formula. It's one of the drawbacks to having an older piece of technology. Sometimes it's not as user-friendly. But either way, we get that same 0.168. So on our notes, that's what I want you to write down for binom. Oh my, I can't write. I think it abbreviates binom PDF. And then it goes in the order of this. It goes n number of trials, comma, probability of success, comma, and then X successes. It has to be written in that order on the older calculators. Newer calculators, you just kind of read and figure it out. Either way, same answer. So from here on out, I'm going to be using that binomial PDF feature on my calculator because I think it's smooth. This question has a substitute teacher who has a 32% probability of being asked to work on a Friday. So that is the chance of success. So then they want to know what's the probability that the teacher will be asked to work 3 out of the 4 Fridays that are upcoming. So this is our X. 4 is our, excuse me, I shouldn't make that noise on the speaker, sorry. 4 is our N, number of trials. So you can go back and use that same formula as before. But I'm going to be using my calculator's features. Now, what I'm going to write down here is for my older calculator users, because obviously that's more challenging. So for you guys, the order that you're going to have to write this in is 4 total trials, probability of success is 0.32, and then 3 of them are going to be successes. So that's for the older calculators. For the newer calculators, you just fill in what they ask for. And you get, I think I did this one already, it comes out to 0.089, which, you know, that no one wants to talk like that. So let's say it's about 9% chance that they'll be called in for 3 of the 4 Fridays coming up. All right, sports. So on average, a basketball player misses 3 free throws out of 8 attempts. So that's kind of a weird way to say that they make 5, right? So they make 5 out of the 8 free throws. So instead of having it as a decimal or percent, you have it as a fraction, and that's okay. We can still type it in our calculator that way as well. But this one's a little more exciting because it says, what's the probability that he misses no more than 2 times? So binomial probability, when you do the PDF menu, it only is calculating for like each integer. So the way I'm thinking of it is missing no more than 2 times would be like, okay, so he misses 2 would be something I need to figure out. And then misses 1. And then what if he misses none? So remember, we're thinking of this in terms of success. If he misses 2 out of 5 free throws, that means he makes 3. If he misses 1, he makes 4. And if he misses 0, that means he makes 5. Now, those of you who have had stats class, this is technically a binomial CDF distribution, but you have to remember like which way the curve is calculating the accumulation. So for PreCalc, we're just not going to do it that way. Not now, at least. Oops. All right, so what I just wrote down in black, those are the number of successes that we're going to be using in our calculator. And I think we're ready to start typing. So on this one, Binomial PDF. We'll be doing, let's see, 5 free throws. His probability of success is 5/8, and he's going to make 3. And then same thing here, binomial PDF. Still 5 free throws, still a 5/8 chance of being successful, but this time he's going to make 4. And this time, 5, 5/8, and 5. So pause the video, type in each of these, and then what you're going to have to do is you're going to have to add all these up. And through the magic of me already keying this, I think we get 0.72 as our answer. Again, rounded, truncated. That was a tough question. So binomial PDF only works for like singular number answers. So there's a little screen on your calculator of what the old ones look like. They don't show you this option. That's like the newer operating system. So if you have an older calculator, I think you can't upgrade your operating system. Not sure about that though. So I'm going to flip to another file, and these are book problems that at one point were assigned to you. I'm not really sure what we're assigning to you this year, but the ones I want to look at are 27 and 28. I think they're going to be pasted onto your lesson here. So Alfonso is taking a 16-question true-false test. So there's 2 outcomes, right? And if I'm just flat out guessing, or Alfonso is, that means his probability of success is 0.5 or 50-50. So 16 questions, so the number of trials, if you want to think of it that way, is 16. And the question is, how many of the possible sets of answers to these questions have exactly 12 correct answers that are false? Okay, so it doesn't matter true, false, like whatever, because it's a 50-50 shot for both of them. So what we're going to do is, alright, this is kind of confusing because we're going to find the probability of it occurring, and then we're going to multiply it by how many different ways we can answer this question. It's kind of a weird way to say it. So here's what I'm going to do. A, I'm going to use my binomial PDF, and then they want exactly 12 correct answers that are false. So like, again, 50-50 shot, so it doesn't matter. But 12 would be my X, let's call them successes, if you will. So, total number 16, 50-50 shot, and exactly 12. And this is going to tell us the probability that this occurs, which I think I did write down. It comes out to roughly 0.028. But now we have to think about how many ways we could have answered that test. So 16 questions, all a 50-50 shot. That's like 1/2 times 1/2 times 1/2, 16 times. So there's 1/2 to the 16th power ways that we could answer this test. Yuck. So I'm just going to write that in my calculator's home screen and come up with my answer. And it comes out to exactly 1,820. I don't know if that was the easiest way to do that question. That's how I did it, though. Thank you. And is everything good? Alright, so then the question underneath it is comparable. A little different, though, this time. I want exactly 8. How many possible answer combinations do we have here? For 8 correct answers, true. Again, 50-50 shot for true, false, so I don't really care whether you're thinking of them as successes or failures. But on my calculator, binomial PDF, 16 answers, 16 trials, still a 0.5. And this time it's exactly 8 successes, if you want to think of it that way. So on my calculator, that probability came out to 0.1964. So again, if I multiplied that by how many ways I could answer this test, which is a lot, comes out to 12,870 of those ways that I can answer the test. So, those kids who just flat out make guesses on any sort of multiple choice or true-false test, I know it feels like you have a fighting chance if you're just flat out guessing, because it's a 50-50 shot, but to get a lot of them correct is tough. Alright, so this question, these are a lot less complicated. The probability of making a sale is 1/5. So you can write it as 1/5. You could also say 0.2, but that would be the probability of success. They have 12 appointments this week, so that's how many trials this person is going through. And then this first question, that they make no sales, if you want to call it success, I guess you could, but it's 0. So again, in my calculator, if I put all this information in, pause the video, try it yourself, but you should get 6.87%. If you wrote it as oh no, that's not right. Time out. I don't know if I wrote down the right thing. I think it's 68%. You know what? Pause. Alright, so binomial PDF. Oh, jeez. It's the day before spring break, and I'm just really tired right now. I won't go home. Alright, 12. Probability of success wasn't very good, right? 0.2. And he's going to have no successes. That is a bummer. Okay, 6, yeah. I just have the wrong thing written down here. My bad. So, like 6.87% roughly. Oh, that's awful. Well, no, that's good, because we don't want no sales. What are you talking about, Bruce? 0.0687. I don't care if you give it as a percent or a decimal. Just don't confuse the two. If your answer is 6.87% and you write that without a percent symbol, that's not actually correct. So choose a method. All right, this time there's exactly 3 sales, so your number of successes is 3. So same stuff, I go on my calculator, type, and I get 0.2362. Or 23.62%. And then 10 sales, I don't think this person has a very good chance of this, because when I think about this, you only have a 20% chance of like selling. So to sell almost all of your appointments, that'd be awesome, but it's pretty small. It's 0.000004 or 0.00004%. Slim chances. All right. So that's the lesson on binomial probability. I'm going to record a separate lesson on the probability distributions, which the binomial experiments will come back. And then, let's see, we're going to start talking about descriptive statistics and eventually the normal curve.